right before the big
So,
lecture.
here's our data. Here's our data, midpoints, frequencies, all the way down. This is the easiest way than trying to enter them in 19, 20 times. Real quick, let's run one of our stats really quickly. This is not necessary when we run these t-tests because it will do it for us. But I want to prove a point as to why we're going straight to technology and we're not going for a manual calculation first. Just want to make sure you understand what the TI is doing. I want to refer back to the test statistic as well. So run a real quick one of our stats. L1, L2. Okay, the average IQ in our sample is 94. So our guts were correct when we said it was lower than 100. The question is it significantly lower than 100? Is it significantly lower than 100? Well, you have to also talk about the sample standard deviation. Now the sample standard deviation is 9, to which some people will respond, what? If it's 9, and the average is 94, if you add and subtract 9 to 94, there's no real significance. But we shouldn't be adding and subtracting 9 from 94. We should be adding and subtracting an inferential adjustment to 9. Central limit theorem, divide by root n, remember that? The root n correction. What you should actually be doing, now I want to show you why we're not going to do that here in a second. The test statistic that we need, t, and the TI will be giving this to us in a second, is found by taking the sample average, in this case 94, subtracting the assumed population average, which in this case is mu, and dividing by the standard deviation of the sample, which is called the standard error, this over that. Now this looks identical to the one for the proportion. Looks identical. And with this data that's right in front of you right now, you could actually calculate the value of this, couldn't you? You could. 94 minus 100, that's roughly -6. S is 9. Root of 61 is just about 8. So you'd be dividing by 1.125. So whatever that is, it's somewhere around -3, -4 altogether. And that's fine. But I found out in the past, when I have students cranking this by hand, they tend to make errors because of all the divisions and things like that. So I did away with that. But even if I was to make you crunch this by hand, you would then have a number on this curve, yes? You'd have a number on this curve. And our job is to find that number, see where it is on this curve, and what we really care is what? The one thing we really care about, exactly, Sherry, is where the number falls with respect to this line of sand right here, correct? What's that line in the sand? On a Z curve, it's about -1.645. But that's a T curve, right? Here's the problem with doing these manually. Okay, I'll turn this off for just a sec. Here's the problem. Oh, you can't see that. Sorry. There's the problem. That number changes based on your sample size. If you remember the Guinness Brewery example and gossip from a couple weeks ago, he invented the T-curve to deal with samples like this that didn't fit on a Z-curve, when your sample was too small or too weirdly shaped to fit on a Z-curve. So in order to use this chart, we have to first find what he called degrees of freedom, which is one less than your sample size. Our sample size is 61. Where's that on our chart? Well, it's large. What the hell does large mean? Now, I've seen there's other t-tables that exist that actually do go up the higher to 100, and 200, and 300, but none of them go from 1 up to, say, 5,000 by 1s. They all have gaps like this in them, which means very often you can't find your exact t-value that you need to demarcate that 5%. Does that make sense? So when it says large, if you look at large, it actually just uses the t-test statistic. That might not be correct depending on how large is. That's why I stopped making students do t-tests manually. There's no point. There's no point because you can crunch the test statistic manually very easily, but then where do you put it? You don't exactly know where it falls. So I let the TI do the entire thing for us. Makes more sense that way, I think. Let's do it. Let's do it. We got our data. We're in here. Let's go back to that test, that t-test. I'm going to restart this bad boy.